In 1n, we have the limit as x tends to negative 1 of the quantity x squared minus 2x plus 1 over x plus 1. That is a perfect square, so I'm going to write that as a perfect square. It factors into x minus 1 and x minus 1, so it's x minus 1 squared. So we have the limit as x tends to negative 1 of the square of x minus 1 over, whoops, I don't know what I was thinking there. Nothing at all, probably. So we have x minus 1 squared over x plus 1. Now, as x tends to negative 1, that numerator is tending to 0, but that denominator is non-zero. So you have non-zero over 0. The numerator is a continuous function, and the denominator is a continuous function. We've got a vertical asymptote. So this is yet another case where we need to look at the limit from each side, a limit from the right and the limit from the left. So here, we're looking at numbers, there's negative 1, there's 0. We're looking at numbers right in there. And then here we're looking at values slightly less than x, slightly less than negative 1, and so our x's are right over here. Okay, so what's going to happen here? Well, we need to examine the signs. These are either going to be infinity or negative infinity. This is either positive or negative infinity, and we've got to figure out which one, and the same for this one. Right, because we're dealing with a vertical asymptote. So we do a sign analysis. Well, the numerator is going to be positive, right? It's not 0 since we don't let x go all the way to 1. In fact, x is getting closer to negative 1. And if you put in a negative 1 or something close to negative 1, well, you're going to get something positive here. So the numerator is positive. The denominator, let's see, if x is slightly bigger than 1 and then you add 1 to it, it'll be over here on the positive side of 0. So the numerator will be positive, the denominator will be positive. That is positive infinity. What about down here? Well, the numerator is still positive, it's squared. What about the x plus 1? Well, x is down here to the left of negative 1. If you add 1 to it, you're going to be on the negative side of 0, and so that numerator will be negative. You'll have a positive numerator, but a negative denominator. So that limit is negative infinity. These limits do not match. They're both infinite, but this one's positive and this one's negative. Since the limits don't match, this limit does not exist.